everyone, welcome to my video. So in this video, we're going to continue studying the power supply units. I'm going to read all of the information from the document containing additional knowledge about the power supply units that come from me and Computing Fundamentals A+ course. Notice that I'm not going to read any information that already mentioned in the last video about power supply units. Please make sure to pause the video at some point to write your own notes. So the power supply converts AC power from the wall into DC power that can be used by the computer like the CPU, GPU, motherboard, storage drives, and fans. The standard the standard advanced technology and standard ATS power supplies provide a positive 3.3 volts, a positive and negative 5 volts, and a positive and negative 12 volts. So 12 volts are DC power. Most modern components require a positive 12-volt output. The 120-volt AC power from the wall flows into the power supply, where it's converted into three DC voltage levels: 12 volts, 5 volts, and 3.3 volts. Each voltage output circuit is referred to as a rail and can power multiple devices. A voltage output circuit is a part of an electronic system designed to produce a specific voltage level at its output terminals. To avoid overloading one circuit, many newer power supplies have two or more positive 12-volt rails. Have two or more positive 12-volt rails. These are known as dual rail power supplies. Separate rails balance the power load between multiple circuits, preventing any one circuit from becoming overloaded. Many power supplies have a switch on the back that turns the power on or off like this. This is the power switch button. Some power supplies have a voltage switch that toggles between two voltage settings, either between 115 and 230 volts, or between 110 and 220 volts. Most modern power supplies eliminate the voltage switch and instead automatically switch between voltages as necessary, which is usually between 100 volts and 240 volts. Most power supplies also have air holes with fans inside. Here you can see the air holes here, and you can see the fan inside. The primary purpose of the power supply unit fan. The first purpose is cooling the power supply unit's internal components. The power supply unit converts AC power from the wall into DC power for your PC, which generates heat. The fan prevents overheating of components like transformers, capacitors, and voltage regulators. And the second purpose of the power supply fan is maintaining airflow in the case. The power supply fan blows hot air out of the computer's case, allowing cooler air from the front of the case to flow in. This helps to maximize cooling by creating a wind tunnel effect inside the case. So the hot air will flow into this position, and the power supplies will blow the hot air out from the back here. The power supply's wire bundle contains a variety of wire connectors that plug into components and provide them with the correct voltage or DC power. Here you can see the wire bundle here that contains a variety of connectors. So those cables above can be fitted into the power supply unit or connected into the power supply unit through different ports and detached from any port depending on the design of the power supply unit. So the power supply can be installed at the top location inside the computer's case like this. And it can also be installed at the bottom location inside the computer's case like this. A redundant power supply is a system that uses two or more power supplies to ensure continuous operation and reliability. Redundant power supplies are generally found in servers and other network devices. A redundant power supply is hot swappable. You can remove and replace a component while the system is still powered on and running without shutting it down. This allows a bad power supply to be removed without shutting the server or device off. It can be replaced the same way. This redundancy keeps critical servers running even if one power supply dies. So here is how to choose the right power supply unit for your computer. The first step to choose the power supply unit for your computer is to examine the wattage. So power supplies use a power rating called watts, which is a measurement of its maximum power output. A simple method is to find the total wattage for hardware components. If you don't see the watts unit label on any hardware component, you can find the watt requirement for each component by multiplying volts by ampersands. The formula is W is equal to V times A. V stands for volts, A stands for ampersand. W stands for watt. Then you can use the power supply unit that offers more wattage than the total wattage on the first step. And so when using the power supply unit that offers one more wattage than the total wattage for hardware components, it will help it will help your system run cooler and quieter and generate less heat, which lowers electricity bills. So for this document, I already see that this information is not that important anymore because what I want you to remember is just remember to find the total wattage for hardware components. That is the easiest method. So one of the power supply's main function is to provide power to components. But if the connected components draw more power than the power supply can handle, they will shut off. We already talked about this information. Okay, the next step to find the right power supply unit for your computer is examine the form factor. Form factor here refers to the physical size, shape, and connector layout to determine if the power supply unit will physically fit in a PC case and connect properly to its components. So the power supply should match the motherboard and case form factor. For example, you should match an ATS power supply with an ATS motherboard or a micro ATS power supply with a micro ATS motherboard. Notice that different form factor doesn't mean that you will see different cables and connectors. The power supply unit might provide the same type of cables and connectors, but with different size, color, and length. So the first form factor is ATS. ATS power supply can be installed into most desktops or PC cases with ATS form factor. The second form factor is the SFS. SFS power supply will be suitable for compact builds and mini ITS PC cases with SFS form factor. So the mini ITS PC cases look like this. The next form factor is TFS, EPS. TFS and EPS power supply can be used for ultra slim desktops, specialized or server setups with TFS and EPS form factor. Ultra slim desktops look like this. Here's how the TFS, EPS power supply unit and cables and connectors look like that can be used for the internet server. Here are some cables and connectors. Here, this is the power supply unit that is used for the internet server. So the next step to find the right power supply unit for your computer is examine the modularity. Modularity can be used for distinguishing between power supply unit devices. It's not that important to determine if the power supply unit can work well with your computer. It can be useful to reduce or eliminate some unnecessary cables. So the first type of modularity is modular. Modular is detachable cables, cleaner builds, which means that you can plug cables into the power supply unit or remove them in case you don't need to use some cables. Here are some ports for the modular power supply unit. You can connect any cable into these ports or even remove any cable from these ports. The next type of modularity is semi-modular. Mm, Semi-modular means some cables are fixed, some detachable. Some cables can be removed. Some cables can be plugged into the power supply unit or removed from the power supply unit. Mm. Here's how a semi-modular power supply unit looks like. Here you can see some cable fit into this power supply unit, and there are some ports to help you connect more cables or remove some cable out of it. Mm. So the final type of modularity is non-modular. Non-modular means all cables fit. You can remove the cables. Here's the non-modular power supply unit, and you can see that all cables fit into this unit. Um, And that's it for this video. Thank you guys for watching my video. And please don't forget to like, share, subscribe, and hit the notification